I'm Reverend Greg and I welcome you to this video in the tutorial series Shaders for Hobby Programmers. In this video we're not going to code a shader, instead we're going to set up the 3D software called Blender to render normal maps for 2D games. After this video we'll be able to turn any 3D mesh like this into a normal map like this. Some of the shockwave normal maps used in the last video were created this way. If you don't have Blender yet, you can get it for free on blender.org or on Steam. It's a great piece of software, but like every 3D software, it's not easy to learn really. I'm very bad at it and just so good enough to create some very simple stuff. So this is a new default Blender project. There's a camera, some lights and a cube in it, and that's it. First, let's set up the camera. But be careful, in Blender left click moves the 3D cursor, so don't do that. Instead, to select an object you need to right click on it or select it in the object tree in the upper right corner. We'll need to center the camera on the X and Y axis, move it up along the Z axis, and rotate it to face down towards the world's center. Now the size of the camera. In the Render tab inside the Properties editor on the right side, there's the Dimension subsection where we can set the camera's resolution. In example to 256 pixels squared and to 100%. We're going to create the normal map in the compositing stage, but to access that stage we also need to activate compositing in the post-processing subsection here. And by default, Blender is not doing a normal render pass. So in the Render Layers tab and inside the Passes subsection, we need to activate the normal pass. Without that, we wouldn't be able to grab the normals in the compositing stage. Now Blender has a color management and for some reason the normal pass is affected by that. The default setting will render the normals wrong, so in the Scene tab inside the Color Management subsection, we need to change the view setting from default to raw. And one last setting for the camera. For this one, we need to make sure the camera is actually selected, and then in the Object Data tab, we can set the lens to orthographic, but depending on your art style, you might want to leave it at perspective. And now we can set the camera so that the object we want to render is filling the image. For an orthographic projection, we can simply change the orthographic scale to do that. And to actually see what will be rendered by the camera, we can press 0 on the numbers pad. So the camera is set up. Now we need an object to render, and this cube's normal won't be very interesting. So let's delete the cube and add Suzanne. Then to rotate Suzanne, press R, X, -90, enter. This will rotate around the x-axis by -90 degrees. Now we want a smooth shading, and to make it smoother even, we can add a subdivision surface modifier with 3 subdivisions when rendering to get a super smooth result. Then we also need to add a plane and set its Z position to -1, so it's behind Suzanne. And to scale the plane by 2, so it fills the view, just press S2, enter. So scale factor 2. Now we won't need the tabs left and right anymore, but 2 more windows now. In the left window I want the UV image editor. In the top right window I want the node editor. And in the bottom right window I just leave the 3D view as it is. To render, just press F12 and the image will appear in the UV image editor. Now we need to turn this render into a normal map, where the Z-axis is pointing straight out of the screen towards the viewer, and where the X-axis is positive to the left and negative to the right, and the Y-axis is positive to the top and negative to the bottom. And we're going to do that in the compositing stage. So in the node editor, we need to display the compositing nodes and check use nodes. Then we can set the composite node to show the result, rearrange the nodes a bit to get some space in between, and remove the node connector. Now we need to add a new color mix node, show its image, set the mix type to multiply, connect the render layer node's normal output to the multiply node's upper image input, and set the lower image color in the multiply node to 0.5 gray. Here we can see the X and Y component of the normal pass, but the Z component isn't visible yet. The Y component is flipped and there's too much black. That's because some color values are negative at the moment, so we'll fix that next. Just add another color mix, show its image as well, and set its type to add. Connect the multiply node's output with the add node's upper image input, and set the lower image input to 0.5 gray as well. So we fixed the brightness, but the Z component is still not showing and the Y component is flipped still. To fix that, we'll need another color node, but this time an RGB curve node. Then we can connect the add node's output to the curves node's image input and the curves node output to the composite node input. Now flipping the green color will fix the orientation of the Y component, and then flipping the blue channel will get the Z component in. Pressing F12 will render the image again, and in the UV image editor we can switch between showing the render layer and the composite output. And that's it already. Just save the file to reuse it over and over again, and if you want to save the composition nodes, you can do so by putting the color nodes into a group and append the node group to any Blender file you want. I hope that helped understanding how to create a normal map for 2D games in Blender, even if you, like me, are not a Blender pro. Until next time.